Hi, Tutor Buxton is here. I would like to welcome you to my channel, and I would like us to continue with estimation. Over the past few sessions, we've got the privilege to learn quite a number of items related to preparation of bills of quantities. And so far so good, we've learned up to walling. In the last session, we did external walls estimation, and in this session, I would like us to do internal walls estimation. For the new viewers, welcome to this channel. For you to get the catch-up videos, I will attach a playlist of all the work that we've done in the description part of this very video. For my returning viewers, words can't express how grateful I am. If you need any consultation with grid surveying, if you need any construction and measurement materials, kindly reach out to the number that is going to be attached to this very video as well. Also, personal tutoring is welcomed and at a very convenient time and a very friendly charges or cost, so to say. Welcome. If you haven't subscribed, kindly do so before we continue. A moment for you is very much in order. And that is fine. Thank you very much for heeding to my call. So today I would like us to do the internal walls estimation. And as usual, we get to learn various ways or easier ways of doing the measurements from this very channel. So when you want to measure the internal walls, there are now easier ways to do that. And that is why we are here, and that is one of the items that I would like us to learn. If you need to do the internal walls, of course, these ones are also done in square meters. And I just want us to learn how to do that in an easier way. Well, normally, when you're dealing with the wall or when you're dealing with a structure with various walls, then it's just important that you find a way to tackle them in a procedural manner so that you don't miss out on some or you don't actually omit them totally. So what you'll do is this. In most cases, you'll find that your drawings have been provided with what you call the grids. Looking at straight into your screen, you will notice that I'm presenting what we call the plan. This is a plan of first floor, of course, first to fourth floor, because we are dealing with a house with numerous floors. So what we have here shows that we have various grids running from grid 1. Okay, when you check vertically on your longitudinally on your screen, you'll notice there is grid 1 to grid 10. Okay, then when you check along the horizontal planes, you'll notice there are grids running from grid A1, B1, and so on up to H1. So it's always important that you take your walls in a procedural manner. So for instance, in this case, I would like us to start with along the longitudinal grids, that is from grid 1, 2, and so on. And of course, we had estimated in our previous session, we had done the estimation of the external walls separately, okay, so that we don't mix them up with the internal walls. So in this one, we are just focusing only on the internal walls, and I would like us to start straight from the grids on the longitudinal axis. And we are going to start from grid 1, 2, 3, 4, and so on. Okay, so what we'll do is this. Along grid 1 is falling on the external walls. So external wall is not going to be part of the estimation that we are doing for the internal walls. So grid 1 is out. We go to grid 2. We check grid 2. Along the grid 2, you just follow it quite keenly, so that if at all there is any wall which you need to take into consideration, it's well captured in terms of the length, and of course we'll get to the section, get the height, and then get the areas and so on. Grid 2 is also out. Then we move to grid 3. Along grid 3 there is an internal wall where I would like us to start. So first of all, after you've identified that wall, just zoom it in properly so that you are able to see it well. So what I've zoomed in, it's nice that you can see along grid 3. Just follow that the dot that is indicating the grid, and then you can see it's starting from this is C1 and then down to E1. You notice that always in my recommendation, these walls you can always take them in a manner that allows you in your identification for the wall. So this is 200 millimeters thick walling internally. Alright, so once you've identified that, the thickness of that wall, and then of course the unit you state here, the unit is square meters, and then the next part is, now we've decided to take start from this is along grid 3, moving all the way from E1 to C1. So we can always decide that the vertical ones, or along the one that are along the grids 1, 2, 3 and 4 and so on, will be taken within the walls, within the ones that are on the horizontal grids, so that we pick on one direction to be taken full, and then on another direction to be taken in within. Okay, so that we take note of the double measurement, especially at the intersections of the walls. So that said, once you've also taken note of that, then we proceed. So along the grid 3, it's going to be from E1 to C1, and that distance is 1.6 meters. Okay, in what I've just zoomed in, you are able to read the 1.6 meters. So what we'll do, we'll consider length at long, just on the side as usual, where we do all our calculations. So the very first length that we're going to deal with here is 1.6. Then we indicate plus. Okay, once we've done that, we proceed so that we find another internal length. Then the other internal wall is along grid 4, and it goes all the way along grid 4. It starts from H1 to F1 is part of external wall, which we had taken into consideration in the estimation for the external walls. So we won't worry about that for now, so we leave it out from that point. But then we'll start it from F1, moving all the way to D1. Somebody will be wondering, how would you identify an internal wall and external wall? Well, if you have, for instance, this now a multi-story building, of course you have, these are balconies. So balconies, they are always identified by an internal wall and external wall. Okay, so you can always check where you have your doors and the windows and so on. For instance, what I've just zoomed in, if you check keenly where my cursor is playing around, you have an external door for access to the balcony. So to me, this is an external space. Balconies are external spaces. Okay, the same applies to that space that is adjacent to the one that I'm referring to. So that means all the three walls are external walls, starting from the one that the door is, and then the other two walls that are showing or demarcating that space. Okay, so all the three, 1, 2 and 3 are external walls, which you won't be much concerned about, or rather you will consider them at the external walls part. Okay, so that means at grid 4, our wall is starting from F1, the internal wall, all the way to D1. So that is what we are going to talk about, or we are going to, the length that we are going to measure. And looking at this, it starts the length, you can see the length has been indicated, coming from this point where my cursor is, then moving all the way up, and this is 2.5 meters. Okay, so we also indicate this to be 2.5 meters, and then we move on to the next bit of it. And the next part, along grid 5, along grid 5 there's another internal wall, moving all the way from grid D1. You can see that grid D1, then it goes up to the grid between grid B1 and A1. Okay, and let's see what we have here. This is let's calculate what we have. Well, I can see it here. It's this is 3.8. okay, we've realized that it starts from grid D1 moving upwards to grid the grid between yeah, you can call it B1 prime or something. Yeah, the grid between A1 and B1. okay, so I'll take the 3.8 and then of course I'll add what I have here. This is 0.8. yes, this is 0.8. okay, yes, so I will take the 3.8 plus 3.8 and then plus 0.8. so that one is taken care of. The next one is along grid 6. Along grid 6, the internal wall is starting from F1 moving upwards to D1. F1 to D1. So let's consider that as well. It's 2.5. okay, look at where my cursor is, and that wall is 2.5 meters. So I will add the 2.5. Alright, then the next part is grid 7. Grid 7, that wall is similar to the one we've done at grid 5. okay, so on grid 5 we got it to be 3.8 and then plus 0.8. well, so we proceed. After the 0.8 we have another internal wall that is along grid 8 as well, and that is also similar to the one we've done at grid 6. So looking at it keenly, so this is 2.5. so we'll add to that another 2.5, then plus moving on. Then the next is at grid 9, where we have that smaller wall and the length is 1.6. yes, just look at my cursor where it's moving around now. We have 1.6. so we add the length for 1.6 and then we add another one. That is the last one. That is the last of the walls along the grids 1, 2, 3, 4 up to 10. okay, then straight away we switch now the grids, and at this time we look at along the grids H1, F1 and so on. So I'd like us to start from the bottom where we have H1. H1 is along the external wall, so we are not going to include that in our measurements now for the internal walls. We check on G1. G1 followed closely, there is none as an internal wall. F1 as well. okay, then we move to E1. E1, there is an internal wall that we'll start from. Alright, so at that point we have a wall coming from, yes, E1. Follow the E1. So it's starting from this is grid 2 and then it moves up to grid 4, and we agreed that at this point we are now going to take it all through to the external faces of the walls. okay, alright, so E1 from grid 2 to grid 4, it's showing us that we have let's see, yeah, the 2.1 plus 1.1. okay, of course these are at the centers, so we are going to add to the external parts. We are going to add to the external parts of those walls so that we have it up to the external faces. The reason being, on the ones to the one that we took along the longitudinal grids, we didn't go all the way. We didn't go all the way to the external faces. okay, so there is that portion that we need to consider the intersections. So we've talked about that, and what we take into consideration now is the 2.1 plus 1.1. okay, so 2.1 plus the 1.1, and then of course we are now going to add The wall, half of it is 0.1 times 2, okay, to cover for the either faces. And then we move on. The next one is what we have here is identical to what we have on the other side. That is now from grid 8 to grid 10. So we can just take what we've done again. So that is alright, we can have it into bracket right from the 2.1, and then we multiply that times 2, and then we add another point. Alright, so grid E1 is complete. We move to grid D1. So from grid D1, it's going all the way from that is now 4 to 8. 4 to 8. So 4 to 8, let's see what we have. 4 to 8, we have 1200 times 1, 2, 3, 4. Okay, that is 1.2 times 4. Alright, so we'll add the 1.2 times 4, and then also 0.1 times 2 to cover for the other bit. Alright, when I say the other bit, I mean let me see, this 1.2 times 4 plus 0.1 times 2. I mean the external faces of the external halves of that particular wall. So we've added that, and the next part that is left that we're covering next is grid C1. On grid C1, it's going all the way. Alright, so we have 2 moving up to, this is 5, 2 to 5. Alright, so 2 to 5, that length is supposed to be 2.1 plus 1.1 plus 1.2. Right, so we'll add that. Okay, let's see what that comes to. 2.1 plus 1.1 plus another 1.2, and then we add the 0.1 times 2 for the reason that I've just explained. And this one is identical to the other portion, to the last end. Okay, so we've taken the 2.1 plus 1.1, so I'll have a bracket over there, plus 1.1, 2.1 plus 1.1 plus 1.2. Yes, so that is okay. Then I will multiply this by 2, then add another part. Yes, so the part between grid 2 to grid 5 is identical to the one that is from grid 7 to grid 10. Alright, so that is also taken into consideration, and that actually gives us the last part of the internal wall that we needed to take care of. So we just do away with that plus and have the equal sign. So that gives us a total length for the internal walls of 40.9. Okay, so 40.9 is now the total internal wall length. So once we have that, then what we have next is now to get the area. Alright, so when you have your total length, the area is now the easier one, because from the length you just need to get the height, the ceiling height. That is now from the finished floor level going all the way to the soffit. Okay, to the soffit of the beam to the top. So we just need to get our section right. We get our section from which drawing it is, read that particular height, and then you'll get your area. When talking about the height, you consider it from the finished floor level, okay, all the way to below the beam on that particular section. So this one gives us a height of 2.55. Okay, This is where it starts, and it goes all the way up to this point. Yeah, do not consider the beam, because the beam is going to be taken care of, and has been taken care of under concrete works. So this is a height of 2.55. all right. So the area, we just do the area on the side here, and this gives us 40.9 times 2.55. so this is supposed to be the total area of the internal walls. This is now the gross area, okay. But then when you refer to our standard methods of measurements, you need to realize that we are supposed to do that area as a net in the sense that we need to deduct the openings, okay. And for the internal walls, the openings that you have are normally the doors, okay. So you have to ask yourself, where do you get the sizes for the doors, and how do you do the deductions? So it's simple. So once you have the gross area, the next point that you need to consider is from the plan that you've used, okay. From that plan that you've used in your measurements, do you have the dimensions indicated? That is option, okay, that should be option 2. Option 1 is to have what you call the door schedule, okay. So just on the side, you've indicated that the door that you have, for instance, let me illustrate here. For instance, the doors, you can just indicate here doors, for instance. So as you are taking off on every grid, you just indicate that now, or you can do it down in the second phase. Once you are complete, you can start the way you started from a grid, for instance grid 3, okay. Grid 3, there is a door. So when you have a door schedule indicated somewhere, then you will indicate that, you know, when you have a door schedule, in most probably you'll be having doors identified as D1, D2, D3 and D4 and so on, okay. So you just indicate here that is D1, okay. So it just indicates the identifications of those particular doors, okay. Then you go to D2. So in this case it's not indicated because there is no door schedule provided. But if at all it's provided, just indicate door 1, door 2, door 3 and so on. So that once you are complete, once you have done taking the measurements, you'll just go to the door schedule and look at that list, okay. So you just cross check door D1, what is the size, door D2, what is the size, okay. So that at the end of the day, you just get the length, the width and the height of those doors, okay. And then you are done. You get by getting the areas. But now that for the one we are using, it's not indicated, so what we'll do, just follow grid by grid, take the sizes. So in this case, we have at grid 3, we are starting with this door, and this door is 0.85 on the width, okay. So it's so what we'll do, these are doors, okay. Now that they have not been identified in terms of numbers as D1 and D2 and so on, it's going to be we are going to follow our procedure of one by one, grid by grid, so that we don't miss out on any. So we'll start from where we started while we are taking our measurements for the length of the walls. And in this case, the first one here is 0.85, okay. So when you don't have the door schedule, you can always get the widths of those doors on the plan. So that is the first tip. So you get the widths of the doors on the plan. But then now for your heights, you can always check the section. If at all you can have idea of the heights of those walls, of those doors. Alright, let's check if at all there is any. If section doesn't give you anything, then you can always go to what we call the elevation. So looking at the elevation here, you notice that also you can't get the heights of the walls or the windows, okay. So what is your next remedy? What you can do, of course, you can get the width right from the plan, okay, it's indicated. But then now on height, you can always do what you call using the standard height. Okay, so the standard height would mean, normally, of course, now internal walls, you just have the internal doors to worry about. In most cases, the doors that you have, they always go up to the soffit of the beams. Okay, so you can always check what is that height from the finished floor up to the beam level, so that you get the overall sizes of the doors. And of course, it's always safer to be on an upper side than on the lower side. So even if the doors will now be lower than or shorter than what you have provided as the maximum height from the finished floor level up to the soffit of the beams, then you'll still be safe. Okay, so you can always take that full height all the way. Okay, but then in my region, doors are always made, some of them are standard, of course, in terms of height. So a height of about 2.4. Of course, the height that was provided in the section was showing the 2.55, but then doors, most of them are at around of height of 2.4 meters. Okay, so this is a 2.4 meters. That is the first door that we have dealt with. So the other door, let's see if there is another. So we move to grid 4. Grid 4, there is no other door to be taken off or to be measured. Grid 6, there is none. Oh, sorry, we move to grid 5. Grid 5, there is another door here, and this is 0.8. yeah, so there's another door that is 0.8 in width. So that is 0.8. We'll stick to the same height in this case, and then move to the other grid. Grid 7 is the next with the door, and it's the same height. So in that point, we have got 2 doors. Okay, of course, can also indicate numbers here by Roman numbers, so that once we are done, you will tally them up. Then grid 8. At grid 8, is there another door to talk about? There is none. Alright, then the other one is grid 9. Grid 9, there is a door of 0.85, this one here. Alright, so that is grid 9, and there is none along the straight or the vertical grids. So 0.85 is another door, so we have it there. Then we go to along the longitudinal grids, horizontal grids. Check the first grid is here. F1, there is none. We go to E1. Along grid E1, there is a door. This door is 1.1. The another one here is 0.9. Okay, so I'm talking about this as the first one, 1.1, and then this other one is 0.9. So those are 2 doors of different sizes. So we have 1.1. Of course, we'll stick to the same height, and then another one is 0.9, and then the same height of 2.4. Of course, these ones are so far we've seen 1, okay, not 2, and then another one here. Okay, so we move next. The next is grid D1. Along grid D1, there is another door, 0.85. The other one is also 0.85. Okay, so on the 0.85 list, we'll add other 2 doors. So 1, 2. Alright, we move on to the next. The next is talking about is C1. C1, there is no door. Those are just openings. They are not doors, they are just openings. And then yes, that is it. So that brings us to the end of those doors that we want to talk about. So here is 4, these are 2, this is 1, this is also 1. So the areas here is equals to width, then we multiply by the height, then times the number of doors. Okay, and then we copy that formula, then we get a sum here. Okay, need to update on that. I need to update on that so that the formula works all through this. Then equal sign, we do a sum. Sum of the areas of the doors that we've calculated, that gives us 16.1. So the 16.1 is supposed to be deducted from the gross area. Okay, so the net area, therefore, net area here therefore is equals to the total area, gross area that we've calculated, and then we subtract from it. We subtract now what we've got as the area for the walls. Okay, there is a small problem there I need to correct. So this is the total area, and then we subtract the area for the doors. Perfect. So our net area for the internal walls is supposed to be 87.495. all right, so let's finish up on the description for the internal wall, and then we'll be good with that part. Okay, so this is 200 millimeter thick in walling internally. Of course, your description should be comprehensive enough, including now you stating in terms of the material and how it's jointed. So what I'll just make this better. So 200 millimeter thick machine cut. We can talk about machine cut walling internally in cement sand 1 to 3 mortar, with every alternating course reinforced in hoop iron. All right, so that is comprehensive enough for now in terms of full description, and of course the area we've already calculated. So if you have typical or identical floors like we do, 4 of them, then the area that you've calculated for one floor, you can always multiply by the 4 floors, so that you have a total area for all the floors that are associated with your building. So in this case we have 350 square meters. Of course, the worry about the rates will be in our next set of series, where we'll be building up the rates that we are supposed to have in our bills of quantities. So we have it all planned, and as we move on, it's getting more interesting. So for every bit, once we've got clearly, and we've got our principles right in terms of estimation, then now we'll be building up the rates which we are supposed to have in the bills of quantities, so that you have a proper bills of quantities with all the rates in place and so on. So that brings us to the end. That brings us to the end of our estimation today, where we are learning the internal walls estimation. I want to thank you very much for watching, and I'm quite confident that it's been worthwhile. You've understood quite properly what we meant to teach in our session today. So thank you very much. Have a great time till we meet again in our next session that is coming very, very soon. For any clarifications that you might need, please just put them at the comment section, so that I will answer to each and every one of them. Before you leave, if you haven't subscribed, kindly do so, and thank you very much. Have a great time till we meet again in our next session. Bye bye.